Okay, in this video we will be using a spreadsheet to find RAM estimates of area, LRAM, RRAM, and MRAM. I've chosen a function for us to work with. We're going to find the area below the curve, f of x equals 100 minus x squared, on the interval 0 to 5. And I want to go ahead and look at this function. If we have the function 100 minus x squared, and we look from 0 to 5, we're looking for an area about like this. And if we used 6 rectangles, 6 subintervals, we would be getting an estimate about like you see here. This would be for LRAM because the left side of each subinterval is what determines the height of the rectangle on that subinterval. If we used RRAM, we'd be using the right side of the subintervals to obtain the height. And for MRAM, we would be going to the midpoint of each subinterval and looking at the height of the function there. And as you can see, with a small number of rectangles, the difference between LRAM and RRAM is how much area changes as I move this back and forth. If we increase the number of rectangles to 40, it looks like that. And then the difference in area from one estimate to the next, LRAM to RRAM, that difference is getting smaller because the rectangles have less opportunity to vary. They are on such small subintervals. And if we increase this quite a lot, we would see that we can't visually detect any real difference. And of course we're interested in talking about this for a very large number of rectangles. So if we were going to calculate this estimate, we would want to use technology if it was more than just a few rectangles, and I'm going to look at how to do that. This is an important part of the process because even after we learn about integration and using calculus to find exact answers, there are still times when we will need to use numerical estimates. So for the spreadsheet, for the problem in your homework, you have a question that asks you to fill out a table that looks like this. So we'll need to know what happens with 10 subintervals, what happens with 50 subintervals, and 100 and 500 for each of these estimates, the LRAM, the left Riemann area, the left rectangular area measurement, the midpoint rectangular area measurement, and the right rectangular area measurement. So we will build a spreadsheet that I think makes sense, that's simple to follow. This could be streamlined, of course. This could be more efficiently constructed and more versatile in its design, but we're going to make something that's easy to follow. So working with first the 10 rectangles on this interval 0 to 5, we can start with a width, and the width is going to be 1/10 of that 0 to 5 interval. So I could just put, I could think about that and say from 0 to 5, 1/10 of that would be 1/10 of 5. Okay, so I could just put that this should be 0.5 for the width. A more dynamic way to do that would be to say that my interval is 5. In fact, let me say that A is 0 and B is 5. And then for this width, I'm going to put that this width equals this number minus this number divided by the number of subintervals that I want, which I don't have to type in 10. I could call it this cell right here, and I'll put 10 here and label it as n. Number of subintervals. Now the reason I can do that, the reason I would like to do that is that I can then construct each rectangle one at a time. If I'm going to number the rectangles, so I start with a 1 there, and then in the cell below it, back up a bit, in the cell below it, I'm going to click in there and say equals, and this means that I'm using a formula, and my formula is simple. For this case, I'm just making an index to label the rectangles. So it'll be this number plus 1. And when this is selected, so it calculates the 2. I didn't type in 2. I calculated 1 plus another 1. And if I drag this down, you see in Excel there's a little square in the corner of that cell. I can drag it down and it'll continue applying that formula to those next cells. So for the first part of my question, when I'm working with 10 rectangles, I'm going to drag it down so that I have all 10 there. Now the width of each of these 10 equals this width, and the widths we're working with are the same for the LRAM, MRAM, and RRAM. We're dealing with uniform widths. So this number is the one I want, and see, that way if I changed the number of subintervals, if I changed it to 20, then the width changes accordingly. So I'm going to start with 10. But what I want to do is drag this down and apply it. But see, I've created it as a formula referring to another cell. And when I drag it down, it refers to C15 instead of C14. So it is all relative to the first cell. And I don't want that. I don't want it to be relative, so that when I move around on the sheet, I want it to keep referring to C14. So what I need to do is I need to put a $sign in front of the column, and I need to put a $sign in front of the row. That'll make so that wherever I apply this formula, it's always going to ask for the same absolute cell, not a relative position. So I have the width of my rectangle all set. That's the easy part. For the interval, the subinterval, I'll put sub L, so the left side of the subinterval, and then over here I'm going to put sub R, the right side of the subinterval, and in here I can put sub M, the midpoint of the subinterval. Now the left side of the first subinterval is going to equal A. It's going to equal this number A. It'll be 0 for us. And after that, we're going to move over by the width of the rectangle. So for that one, I'm going to put 0. That's A. And for the second one, and all the rest of them, I'll take the left side of the previous rectangle and I'll add the width. So here, these are the left sides of each subinterval. 0, 0.5, 1, 1.5. For the right, I'll do the right ones first. For the right one, the right side of this subinterval is simply this left, the left part of the subinterval plus the width of that rectangle. And if I drag this down, and you'll see that these are all, most of them are the same numbers staggered down, because the right of the first subinterval is the left of the second subinterval. Now the midpoint is going to be this the left side of the subinterval plus half of the width. So I'll put the width divided by 2. I'll drag that down, and these are all of the midpoints for the subinterval. Now, to determine the height, we need to know the height of the function at each of those points. And f of the left side, we need to know the function at the left side of the subinterval if we're going to make the LRAM estimate. So the function's value at the left side of the subinterval, we're going to need the function 100 minus x squared. So this cell we type in equals 100 minus this number squared. I put enter, and the first one is 100. Now my next column is going to be f of sub m, that's the midpoint of the subinterval, and then I'll need a column for f of sub r. And to find these numbers, I'll need the same process. I'll need 100 minus this number squared and 100 minus this number squared. Now, if I've arranged my spreadsheet nicely, I get 100 minus the corresponding, the right side of the subinterval goes into the column I'm making for the function's value at the right side of the subintervals. And if I drag these three formulas down, they'll fill in to get all the necessary information lined up there. So I've calculated the function's height at each of these places. Now what we need is the area for the left side, and we'll need another one for and then the area for the right side. Take the height of the rectangle at the left subinterval and multiply it by the width of that rectangle. And in order to drag this across to the other columns, I'm going to put a $ here to show that this is always going to come from the B column. Then it should drag okay. So the area for that first one is 50. That's coming from 100 is the height and 0.5 is the width. If I drag this over, my other areas are using different heights and the same width. I'll drag that down, and then the LRAM equals the sum of these numbers. The MRAM estimate is equal to the sum of these numbers. In fact, I could just drag that over. So the sum of these numbers is the RRAM estimate. So that's how you would do this for 10. For 10 rectangles, we would get this as our estimate, and if you wanted to extend this to have more, we could extend to 50, and you see that now the width has changed, but we can drag this down. I think this should work to drag down and go to 50 rectangles. A little further. Now if we drag down to 50 rectangles, we can change this to go all the way to, we want it to include 500 eventually, and as long as it's adding up blank cells, it won't be wrong. So I'm just going to put 1,000. And these are our new estimates. We have smaller rectangles, but there are more of them. If I change this to 100, then I need to drag these cells down and continue this pattern and see my widths are changing correctly. A couple more. This estimate, you see these numbers are close, more precise as we're doing it now with more smaller rectangles. Okay, thank you for listening. I hope that helps.